So we are going to talk about conic sections. We'll start from the get-go again. So this is section 9.3, which is page 626, and this is circles. All right. So what we're going to deal with here are our conic sections. And again, section means, sect means cut, okay, to cut things apart. Conic is the name of the shape that we're going to be working with, the starting shape. And what a conic looks like is this. This is an example of a conic. A conic is a double cone that's attached at the apex there, at that tip. Okay? And so if you take two ice cream cones and glue them together, you get a conic. It's one object, okay, not two separate objects. So that's called a conic. And what we're going to do is we're going to take these conics and we're going to slice them with planes. We're going to peel them apart, and we're going to take a look at the cross-section where the planes slice through and see what kind of shape we get. And so for our first shape, the plane's going to come in. It's going to slice through the conic. Notice that it's slicing through perpendicular to the vertical axis. It goes straight across. And when that top piece finishes falling away and the conic tilts towards us, we're going to see what kind of shape we get. And so what we end up with is the cross-section in red, which is a perfect circle. So that's one way to slice a conic. And that's the shape that we're going to be dealing with today. What we're dealing with in the rest of the chapter are the other three shapes that we're going to get by slicing conics at different angles. Okay, so that's what we mean by conic sections. We're cutting conics apart. Now, when we talk about circles, let me shut that down because we're done with it.
I think it's slicing with planes and airplanes.
No, planes, flat sheets. The definition of a circle, guys, is the following. A circle is the locus of points Locus means collection. The locus of points in a plane, so it's a flat shape, that are equidistant. What does equidistant mean? Equal distance, right? Equidistant from a given point. That given point is called our center, and that equal distance is called our radius. And so those are the two important parts of a circle, are the center and the radius. Okay, everybody got that? Now, I'm not going to test you on the definition. I want you to understand the definition, though, so that you understand the concept of what a circle is. It's very important that it says in a plane, because if it's not in a plane, then we can go equidistant in 3 dimensions, and then we actually get a sphere rather than a circle. Okay? So if I change that to in 3 dimensions, then it becomes a sphere. It's a different object. Okay, what do we mean by this locus, this collection of points? Well, what we have here is a construction of a circle. Here I have predefined the length of my radius. The length of this segment down here is the length of this segment. Here is my center, my fixed point. And by dragging this control point, this arm is, and the point on the end of it is going to draw out a series of points that are all this distance away from the center. Okay, so this is what we're talking about in red, guys, when we talk about the locus of points. These are all individual points, but they're infinitely close together. And so as I continue to go very slowly over this, we can see that these points, when they're grouped super closely together, makes a solid circle. Okay, everybody sees how that works and understands now what we mean by the locus of points, that collection. There's our circle. Now, if we want to change the shape of the circle, how do we do it? Change the radius. So if I take the radius and I make it longer, and now I drag this around, now I get a different locus. Now I get a much larger circle with a bigger radius. If I want to make the circle smaller, then I make the radius smaller. Does everybody see how that works? Okay, so that gives you some background on circles. Now, what we're going to be doing is we're going to be working with graphs and equations of circles, and those are very, very easy to work with, and that's why we're starting with section 9.3. Okay. So the standard form of the equation for a circle is x squared plus y squared equals r squared, where the center of the circle is at the origin, 0, 0, and the radius is equal to the square root of r squared, which is r. So it's going to be, the radius is going to be the square root of whatever number appears on the right side of the equation. The x and the y represent the x and y coordinates of all the points that are actually on the circle itself, on the circumference. So for example, we might have something like x squared plus y squared equals 4. Now, the reason that we know that the center of the circle is at 0, 0 from the equation is that there's no number lumped in with the x that's being squared, and there's no number lumped in with the y being squared. It's just x squared and y squared. Later on in the chapter, we're going to see other numbers being squared with the x and the y. That indicates to us that our center is no longer at 0, 0. We have 4 shapes to learn: circles, parabolas, ellipses, and hyperbolas. We're going to learn each of those 4 shapes one at a time, and on each of those 4 shapes, they are going to be anchored with their center or their vertex, in the case of parabolas, at 0, 0. They're never going to be anywhere else right now. They may open up, they may open down, they may open left, they may open right, there may be different sizes, but they're always going to be anchored at 0, 0 until we've learned all 4 of our shapes and the basics. After we've learned all 4 of our shapes, then we're going to start to move them around in the next section. Okay, everybody got that? So we will eventually move these, but for purposes of just learning the basics, these will not move. The nice thing is when we go to move them, the way that the numbers appear in the equation to allow them to move around from 0, 0 appears the same way in all the equations. So that's why we'll learn them all separately, and then we'll lump them all together into one section where we start moving them around, because they all work the same way. Okay, so our center on this is going to be 0, 0. The question is, what is the radius? Right now it is. That's what we just got through talking about. We're going to learn these all at 0, 0, all the different shapes, and then we're going to start moving them around, but not today. Today the center is always going to be 0, 0.
Yeah, no, so for circle, it can change, we're just not learning that yet.
We're just not learning that yet, exactly. Okay, what's our radius here? Square root of 4, which is equal to 2. Remember, this is r squared, so that makes r the square root of 4, which is 2. Okay, so that's how you can identify your center and your radius from looking at this. Now we can actually graph this thing. Let me move this over. And then to graph this, let me get my graph grid here. Make it so it fits. Okay, our center is at 0, 0. You can put a dot there. I like to put an X there because I'm going to use points to indicate the points that are going to be on my circle, and the center is not on the circle. It's inside of the circle, right? It's what anchors the circle where it is. So I just like to use an X, but you can use a point. There's nothing wrong with that. The radius is 2. It's easy to go to the right of the center 2 units, to the left of the center 2 units, up from the center 2 units, and down from the center 2 units. We cannot go diagonally like this 2 units because that's not actually 2 units. That's longer than 2 units. That's 2 times the square root of 2 units. Okay, so that's about 2.8 units. That's not 2 units. So diagonally, we don't know exactly where 2 units is. So all we do is we use 4 guide points: top, bottom, left, and right, this distance from the center. And then what you're going to do is you're going to draw your circle in. And so what I recommend that you do is use a dotted curve so that you can kind of go back and adjust it until you like the way it looks. And then once you like the way it looks, then you can go back and make it solid. So that's a pretty decent circle. Now, is that a perfect circle? No. Is it good enough? Absolutely. What's important is that you make an honest effort to make it a round circle, and it must go through all 4 of your guide points. Do not give me a perfect circle that misses guide points. That is not okay. Okay? Even if you just miss by a little bit, that's not okay, guys. It's got to touch the right points. Otherwise, you're going to lose credit. Okay? So don't do that. Don't give me one of these. That is not a circle, last time I checked. Do not give me one of these. That is not a circle. That's an amoeba or something. Save that for science class. Okay, those are not acceptable, guys. You need to make an honest effort and make sure it goes through the guide points, and as long as you do, I won't have any problem with it. I'm not expecting it to be perfect. Okay? All right, questions about graphing that? Let's do another one. X squared plus y squared equals 12. What's the center? What is it? So 0, 0. What's the radius? Square root of 12, but we can simplify that. What does that simplify down to? 2 square root of 3. Very good, right? Because 12 is 2 times 2 times 3. Right? 2 times 6, which becomes 2 times 2 times 3. And then we can pull the 2's out. Now, as far as graphing this goes, how do I know where 2 square root of 3 is to go up, down, left, and right? How are we going to know exactly how big that is? Here's my center, 0, 0. How far do I go to the right? What can we do? Calculator. Exactly. Punch it into your calculator. So you go to your calculator. Oh, looks like I shut my calculator down. Let's launch my calculator again. So the square root of 12 is about 3.5. Just round it off to the nearest tenth. And so this is about equal to 3.5. Don't write that the radius is 3.5. Write that the radius is 2 square root of 3. But for purposes of graphing, we can use decimals on the graph. 3.5 to the right, 3.5 to the left, 3.5 up, 3.5 down, and then you draw your circle in. Just to save time, I'm going to cheat. There we go. So, any questions about how that works? So that's one type of problem you're going to have. Another type of problem is they could ask you to go backwards. Instead of giving you the equation and asking you for the center and radius and the graph, they could give you the center and radius or a picture of the graph where you could get to the center and radius and ask you to write the equation. So let's look at one of those. What happens if they tell you that the center is 0, 0 and the radius is equal to 5 square root of 2, and they tell us to find the equation? Well, center 0, 0 means it's x squared plus y squared equals r squared. So how are we going to find the actual equation then if we know that the radius is 5 rad 2? What do we do with this? Do what? Yeah, plug it in, right? We just plug it in. So x squared plus y squared equals, don't forget the parentheses, 5 square root of 2 squared. We plug it in, and then we have to do 5 square root of 2 times 5 square root of 2. What's 5 times 5 on the outside?
25.
What's the square root of 2 times the square root of 2?
2.
And what's 25 times 2?
30.
So x squared plus y squared equals 50. There's our equation. So do you guys see how easy that is? Okay, so they can go forward, they can go backwards. There's one other type of problem I want to show you, and then I'll get you going on the homework. The other problem that you need to know how to do is, what if they tell you that the center is 0, 0 and that the circle passes through -3, 4. Find the equation. Well, from the 0, 0, we know it's going to be x squared plus y squared equals r squared. The problem is they didn't tell us the radius, did they? But we can find the radius because we know that the radius is the distance from the center to any point that's on the circle. So we can actually use our distance formula, which is why it was in section 9.1, to actually find this distance, and that's the radius, and then we plug that in for r and square it. But there's another way we can do this, guys. We've talked about this before. Anytime you have a point that is on the graph of an equation, that means that when you plug that point in for x and y, it must make the equation true, which means that -3 squared plus 4 squared equals r squared, which gives us 9 plus 16, which gives us 25 equals r squared, which makes r equal to what? Now notice I did not put plus or minus in. Why not? No. Wouldn't make it a negative distance. What makes something a negative distance? Nothing. You can't have, that's the point. You can't have a negative distance. It doesn't exist, right? Distance has to be positive. Right? If you're 6 feet tall and you stand on your head, you're not negative 6 feet tall, right? If you stand in a 6-foot hole, you're still 6 feet tall. You're just 6 feet tall standing in a hole.
Well, if you're standing on your head, you're like 3 feet. You get 6 feet on your head. You know what I mean? If your head's on the ground, if you're standing on it.
I don't know. Let's measure Casper, and then let's stand him on his head and measure him again and see if there's a difference.
Standing on my own head.
If you were, how would you stand on your own head? I want to see that. Come up and demonstrate that for us. We'll help you. We'll twist you and bend you so that you're standing on your own head.
Yeah, like
oh,
standing
Casper.
on your head, you know? Like my head's on the ground.
So can we all agree that that makes no sense whatsoever and that you're still 6 feet tall? No matter what shape you can torch yourself into, you're still 6 feet tall?
You don't understand what I'm saying.
You don't understand what you're saying,
I
Casper.
do understand what I'm saying.
All right, you think about how to express that to us and then ask me again, okay? All right. So, here's the thing, guys. We now know what the radius is. We can now plug it back in and square it, right? But the truth is we really don't need this because all we're trying to fill in is r squared anyway. We're not really trying to fill in r. So aren't we really done when we get to here? And now I can just plug that back into here. And so our equation then is x squared plus y squared equals 25. So you don't have to take the square root because you might have to break it down and simplify it. And then you're going to turn around and have to re-square it again. It's just going to get you back to where you started if you do it correctly. If you don't, if you make a careless mistake, you're going to make a mistake and get the wrong answer. So stop at r squared and then just plug r squared in instead of going all the way to r. It saves you 2 steps and possible careless mistakes. So the distance has to be positive, so you don't do plus or minus, but the truth is we don't have to square root it anyway. Now, why is it that we could do it this way instead of using the distance formula? Well, the reason is, guys, that the equation of a circle is nothing more than the distance formula. Remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Right? Well, if I do x2 minus x1, what do I get? What's negative 3 minus 0? Negative 3 squared. That's right there. If I do y2 minus y1, what's 4 minus 0? 4 squared is right there. And then if I want to solve for d, which is really r, I take the square root of the whole thing. Isn't that what I'm doing down here to find r? So do you guys see that this is nothing more than the distance formula? That's how you find the equation of a circle, is by just starting with the distance formula. We could actually derive it, but we won't bother doing that. but it just comes straight from the distance formula. It is the distance formula. Now here's the big question. What is the distance formula really? It's another equation that we know, another theorem. Yes, that you guys know, that you've used for years and years and years.
He's like, but what is it really? I don't know.
Name a theorem that you guys know. Pythagorean theorem. The distance formula is nothing more than the Pythagorean theorem, a squared plus b squared equals c squared with coordinates. A squared plus b squared equals c squared. A squared plus b squared equals c squared, and then you square root both sides. So those things are all one and the same, just different applications of them. So does everybody see where this comes from? Okay. All right. Any questions before I give you the homework?